voltage. There are 4 12-volt blocks in a chain. So this is enough. I want to try 72 and didn't before. We have to cool the amplifiers for this. There's a reverse switch. Yes, the system can drive backward. It's maybe interesting in this track, but not really on public use. Optional is to override the pedal assist sensor up to 6 kilometers. That's also a point for the legal stuff in the next chapter. That's what's done with the PWM hardware. This is the scheme. So we have a power source, our central microcontroller, where are also the amplifiers. 2 wires to the hub motor, which are the sensors. These are small signal cables, and the power cord, which is a force cable, more current. And you get the gas shift in the pass. That's the basic scheme. Yes, the power. We need batteries. If anything is better, we would take it, but I think at the moment we will stuck on this and use classical heavy batteries, different technologies. Depends on the prices, I think. Yes, first of all, latest accumulator technology is always a heavy part. If you build vehicles, you know it's always a point of weight. And with these batteries, you fastly have 30 to 40% of the whole bicycle, your batteries. Of the whole bicycle weight are your batteries. These bikes are driven with lead batteries. They are the cheapest, they are affordable. I have always 2 packs to change them against each other and load other while driving the first one. And there's also possible to drive with nickel metal hydride or lithium ion. But this would be much more expensive. Especially lithium ion is this scale with 48 volts and about 7 ampere hours. This would be really expensive and no tests so far. So everything I do here is to chain up 12-volt blocks and with different ampere hours and resulting different weight. So small bicycle has 7 amp hour on board. This tricycle is built about 12 amp hour blocks. This means the small bike has about 9 to 10 kilograms battery in it. The whole bike weighs 20. That's 1/3. And the tricycle has about 14-15 kilo of batteries aboard. That's also half the weight of the whole thing. So batteries would be a nice thing. Let's see what's happening in the next years. Charging hours are also a topic. It's classical regulated charge, so you have 5 to 6 hours reloadings, and so you will need more packs to change. We thought about to build in the batteries into the frame, into the whole system, but with this long charge times, that's not a topic because you cannot change the packs, and the bike would be locked to the power plug if you want to recharge. So we still work with systems where we can take the batteries out of the bike and plug another one in. That's a feature you don't have with electric cars because they are using 100 or 200 kilograms of access. No one can lift this on one point day-to-day basis. Here you can do it. That's okay. It's the easiest way. There's an example for the distance which can be managed for this small bike with 7 amp hours and 48 volts. We can drive about, that's a typo, 30 kilometer distance by 25 km/h. That's the point. That's around. It depends for sure on the topology you drive. It depends how much you drive at top speed, at the best that's the best power situation for the motor, the less consumption, the best efficiency. If you use the motor to speed up with its torture, you will burn more echo, more power, and your final distance will go down. You cannot drive so long. With this trike I do 25 kilometer regularly, and then the 12 amp hours are burned. I knew my track, so I can handle the curves and stuff, and I'm able to burn it in 25 kilometers in about half an hour. That's really heavy for the accumulators, but it's a solution to get on without gas. So, hackability. Okay, digital controller, any current, so we can do some stuff with it. First of all, is interesting a monitoring system. If you drive blind, well, what I do with this? I have my battery. I have power if it's fully charged, and you feel it gets slower and slower. You have less torture if the battery power goes down. So the first thing would be a monitoring system for voltage and amp during driving, not just in the garage for testing. As I want to build a monitoring system on a local display to see what's going on, and a battery status, which could be drawn by from this information, would be the first interesting thing, especially if you want to know when it's finished and you have to push all the lead around with your pedals. So this would be the first. Recuperation is a point which is also interesting and also possible with this microcontroller technology. It means to bring power back into the batteries from the driving situation, which can be two points. If you brake, if you want to brake, you use a special brake switch, and then the motor will do an electronic slowdown. For sure, you cannot use this to brake now as a situation where you need this. It's not possible. You have to do it slowly to use this motor power back and bring it back into the accumulator. The second thing is there is a top speed for these motors, and if you reached on this top speed, you can raise your force, what you pedal into the system, but it would not bring you, make you faster. It will save your power. That's the point. So you have a definitive top speed for this motor, depending on the motor type and the voltage driven. And at this point, if you raise your force into the pedals, then you will save accuracy, not as a rate much more. So that's a way to save energy and to get it more further. We want to build a throttle with these Hall sensors built into the wheel. We are able to know about our actual speed, and 25 kilometer as a limiter would be a nice thing for the legal situation as what we want to do. So we can build larger motors, faster cars to use on campsites like these or anywhere, but are also able to drive out on the streets with this. Steering support is not directly connected to this electronic system for motor power, but I will do this with this track. This will get an RC car I want to build in the steering. Still unknown terrain. I talked to people here on the campsite which they were interesting recommendations about this. We have some tricks. It should be possible to do some tricks with this pulse width modulation, depending on the torture which is needed or the driving distance at high speeds. It may be possible to do some energy saving by software in aka chip tuning for electronic bikes. It should be possible to have certain states where you can not drive your normal regular PWM like in the default routine. There should be possible to use some tricks to you have some modes to switch between different modes, driving modes, and to use this to save some energy. Anti-block system for the driving wheel would be an idea. The Hall sensor would also tell us if we brake with this wheel, that it now freezes, so we can freeze a brake if this is possible. That's all a situation which we can handle in the microcontroller. And also a very good idea is an immobilizer. If we shortcut the motor, no one wants to drive it. It would be really hard to get it on because the magnetic ring would block against the coil. So we have a type of an immobilizer. No one wants to drive this car away with this harm. So about the legal situation in Germany and EU. This whole thing, what we're doing here is a regulation from 2002. It's an European-based decision, so it's not directly regulated to any German or France, any other countries. It's from the upside, I would say, because I think in Germany no one would come on this idea to allow people these. We have too much regulation, too much license stuff. But in this situation, it's possible to do this from EU base, and the regulation is what is first point. Off-road, you can do what you want for sure. It's also possible to think about single admissions, so to build faster bikes like a scooter, 45 kilometers stuff, and then get an admission for this from a technical instance, certification instance. But I didn't do that at this point. Maybe we want to try, but it would be a long way and would cost money. It's not so good. And there's a Swiss special I will talk about later. First, EU, Pedelec. Pedelec is a nice word for it. They just need any topic for this. The regulation says you can have an electronic motor with a force of 250 watt. That's an average force. So you can have peak forces for acceleration which are much higher, about 200 to 400%. So it could be 700 watt at an acceleration situation. But at the average, you only are allowed to drive with 250. The maximum speed would be 25 kilometer. And now that's the point. You need a pedal assist sensor. It's built here in front in the chain wheel, and it's a direction-based rotation sensor, and you have to pedal, and if you pedal first, after that then you can use a gas shift to accelerate. You cannot use a gas shift alone. If it stands here and you push the shift, nothing happens. That's what the regulation says. You have this pedal sensor, and if you pedal, you can accelerate. With this little trick, it was possible to keep it totally license-free and without insurance, and that's the point where we're doing this, and why we can use it outside on streets without any problems. So, like regular bike situation, you even do not need a helmet. It's not a must. You can drive on any streets and use bikeways like a regular bike, which also means in a city or everywhere else you can go on the sidewalk, or drive through the park. It's no problem, just a normal bicycle. There's no sound. It's really silent, and no one will get annoyed about this, even if you have a little bit higher speeds than others in the park. The driver must be 15. I think this is the only extension to the regular biking thing. You have to be 15 to drive this on the street. And the bikes must be roadworthy, like everything, which means lights and reflectors and stuff, for sure. 2 brakes and all this. But if you fulfill these regulations, it's possible to drive 25 kilometers like the old Mofa without any driver license and stuff. It's very, very nice. This is a